Welcome to section 12.2, rational functions. This is video number 2, and in this video we are going to be graphing rational functions. This is the second video of 3, and so this video should help you finish up your graphing pages in your Missing book. So let's get started and understand what we need to do to graph rational functions. First of all, there are 4 steps that we need to follow. For graphing rational functions, we have 4 steps. Step number 1, we need to identify the vertical and horizontal asymptotes, which we learned in video number 1. After that, we're going to graph those asymptotes using dashed lines. And we can graph vertical and horizontal lines if you think about what we did in I believe it was chapter 5 at the very beginning. We're going to have horizontal and vertical lines, so we're going to follow those Hoy-Vux rules. So we'll have things that have 0 slope and are y equals, so we'd have a horizontal line, and we would have a vertical line that is undefined and have an x slope, or have an x-axis cross section. So step number 3, after that we would make a table of values. We'd choose x values on both sides of the vertical asymptote as well, so that way we can see where things kind of reflect or have symmetry. And our step number 4, we're going to plot points and connect them with smooth curves. The curves may get close to those asymptotes, but they will never touch them. So if you end up having a situation where you're getting an x value or a y value that gets that crosses an asymptote, that means you need to second guess your mathematics and see if you should redo something. So now let's try this stuff out. So you should have this Missing page. We started working on it on Friday, and so on this Missing page we're actually going to zoom in and we're going to go through each and every one of these, each and every one of these problems. Let's see if I can actually do this without it being weird on me. So graphing rational functions using asymptotes. We have this equation right here, y is equal to 2 divided by x plus 1. We need to identify the vertical and the horizontal asymptotes. So the vertical asymptote is essentially we are making all this x plus 1 equal to 0. So we're going to subtract 1 from both sides, and x would equal negative 1. So our vertical asymptote is that x is equal to negative 1. Our horizontal asymptote is everything that was off to the side there, and so in this case our horizontal asymptote is actually our y, or our x-axis, so that y is equal to 0. We're going to have a horizontal line. So now we need to graph these using dashed lines, and I'm going to put a check mark there to show that we're going to do that right now. So our vertical asymptote, I'm going to graph at x is equal to negative 1, so we're going to do a dashed line at x is equal to negative 1. So we'll finish this up by moving things down, so just a dashed line. And then after that we're going to make a horizontal line at y is equal to 0. So here is a horizontal line at y is equal to 0. So there's our 2 asymptotes. And as you notice, they're pretty close to the origin, which is exciting. That means we're going to be able to really see our graph. And from there, we can now start to think about our table of values. So I'm going to rewrite our equation off to the side here so we can see it. We have y is equal to 2 divided by x plus 1. And I'm going to zoom in a little bit so we have some space. So we need to make a table of values. That means we are going to make an xy table. And we are going to have some values within this that'll help us get some input and output values. So thinking about this, I want you to be very careful with your table of values that you choose. Make sure you're picking values that are on either side of your vertical asymptote. So our vertical asymptote is at that x is equal to negative 1, so our values should be at like maybe a -3, -2, but then also we need to have some values that are like at 0 and 1. So I'm going to choose the following values. So here are some of the numbers that I've chosen. I'm going to choose -3, -2, -3 halves, because that's right around that -1. I'm going to choose a -1/2, because that's on the other side of that, and I'm going to choose 1 and 2, or 0 and 1. So I'm choosing those numbers because they get pretty close to our vertical asymptote, so we can see how everything behaves around that. But then also it's not just touching on that vertical asymptote, because we know when x is equal to -1, our problem is undefined and it actually can't give us an answer. So after that, we need to put that information into our equation. If we were to put a -3 in for x, we'd have 2 over -3 plus 1. So we have 2 over -2, which is equal to a -1. So our y value at -3 is that. I'm going to fill in the rest of this table, and we will then move on from there. So the rest of the table is now filled in. We essentially just put in 2 to our problem, or -2 into the problem, and when we did that, we got a -1. 2 over -1 equals -2. Did the same thing for -3 halves, did the same thing for -1 half, same thing for 0 and 1. And after doing all of that, if we actually look at these values, they share a simple, really pretty cool pattern. Similar to when we were doing quadratic equations, if we look at this, we have numbers that are negative and we have numbers that are positive, and the numbers reflect each other. They're kind of, it's the same number, but it's opposite. When we did quadratic equations, what we could essentially figure out, if we had a -1, -2, -4 for some things, we would expect to have a -4, -2, -1. So this is pretty similar. However, if you notice, we also have opposites happening. So now our last step is to actually plot all of this on our graph. So we're going to plot these points on our graph. Let's start out with this -3, 1 point. So we have -3, -1 for one of our points. We then have -2, -2 for another point. And then we have -3 halves, -4. So -3 over 2, -4. So there's our other point. We also need to plot the corresponding points on the other side of our vertical asymptote. So we have -1/2, 4, 1, 2, 3, 4. We have 0, 2, and 1, 1. So from there, we technically could, looking at all of this, we probably could have also picked out what is going to happen at -4, what is going to happen at a +2 for x, and actually finish this up. But our last little step is to connect these points. And if we look at how they connect in a nice little curve. We're going to do it also on this other one. Now what I notice about this graph, and hopefully what you're noticing about this graph, is our points never cross our asymptotes. As well, we also have this interesting line of symmetry, and if we were to actually draw a line of symmetry here, we'd have a line of symmetry that kind of goes diagonal. So if we were to take this side of our graph and fold it on top of this line of symmetry here, we would end up with this part of our graph completely reflected. So that's kind of cool. We have an interesting thing going on. It's we have a line of symmetry, but our line of symmetry is on an axis. So actually we could probably even figure out that line of symmetry equation. It'd probably be y is equal to -x plus or -1, and that would be our line of symmetry for this particular situation. However, I'm never going to ask you that information. But either way, we have a cool graph. Let's now do one more graph, and then you will be free to work on your homework. We have graphing rational functions using asymptotes, and we have y is equal to 1 divided by x minus 2 minus 4. So first things first, we need to identify our vertical and horizontal asymptotes. Our vertical asymptote is all based on this x minus 2 is equal to 0, so setting that bottom part equal to 0 so we can find where it's undefined. We would add 2 to both sides, and we have x is equal to 2. So there is our vertical asymptote. Our horizontal asymptote is all based on that extra little bit of information off to this side. So our horizontal asymptote is y is equal to -4. So from there, we need to graph our asymptotes. So we need to actually do that. We have x is equal to 2. X is equal to 2, so we have a vertical line here. So let's finish this up a little bit. So we'll have a vertical line there. Now our horizontal line is y equals -4. So we're going to draw a horizontal line at -4. Finish that thing up. So we have a horizontal and vertical line, and our last little step for this equation is to make a table of values. So we're going to rewrite the equation so that way we can just focus on this part. And then we will make a nice little table. We'd have x and y's, and it looks like we need to keep our x values around that x is equal to 2. So let's pick some x values that are above 2 and some that are below 2 and see how that works. So some x values that we could look at are maybe, let's think about this. So we're going to need something that's near 2, so we could say maybe 5/2. And some numbers that are above that, we'd need maybe 3 and 4. And let's pick some numbers below that same point. So let's pick 3/2, 2, 1, and 0, so we can see how things work. So we're just going to cut this a little short. On the end, we won't do that last little part. So let's put in some answers for those y values. If x is equal to 4, we'd have 4 minus 2 on the bottom over 1. So 4 minus 2 is 2, so 1/2. Minus 4, we'll get -3/2. -3/2. Now we're also going to do that for some other points on here, and we'll fill out this table and get it all worked out. Okay, so I filled out the rest of this table, and I actually realized that I made a little mistake. I shouldn't have picked the number 2, because when x is equal to 2, that whole equation is undefined. We already knew that. I was just being silly, and I hope you guys all noticed that when I was actually making the table. Anyways, we have the points 4, -3/2. We have the point 3, -3. We have the point 5/2, 2. We have the point 3/2, -6. We have the point 1, -5, and 0, -4/2. So those are our points. Let's see how they end up graphing. We have x is equal to 4, -3/2. So 4, -3/2, we're going to have a little point right there. We have the point 3, -3, cool. And we have the point 5/2, -2. So there is sort of our turning points. As well, we have the points 3/2, -6. So we have a point right there. We have 1, -5, and we have 0, 4/2. So here we go. Let's draw our graphs. So you'd end up with a nice little graph that looks something like this. Kind of cool. We were able to graph both of our functions, and as we can see, we end up with some pretty interesting patterns. It's kind of neat to see these little curves that happen, and also make sure that you always, if you end up having issues with your asymptotes, you need to make sure that you are not getting or touching them as you make your graphs. I hope this helps. Keep working this out. Practice a couple of practice problems, and as always, if you have any questions, be sure to ask. Thank you. Bye.